Okay, hello everyone. So today I'm going to be demonstrating hang time, and I thought that it would be pretty unique if I do it through the Minecraft approach. Now, one of the things in Minecraft that takes a while to get down would be an arrow. So I'm going to shoot an arrow directly upward like this. Okay, and I'm gonna wait for it to fall. And the idea is I'm going to compute for how long or how high it actually goes through the laws of physics. Okay, so hang time involves getting the time of flight and calculating. So I have my timer off camera. I'm just gonna press start on the timer as I fire this upward. 3, 2, 1, and go. Okay, the arrow is about to fall. There we go. Okay, so according to my timer here, it took 5.52 seconds for this arrow to fall back to the ground. So let's say we want to compute how high it actually went. So let me just get my Paint application. Okay, quit Minecraft for a bit. Okay, so according to my timer, it took a total of 5.52 seconds for it to fall back to the ground. And this hang time is actually, if we make a sketch of the scenario, so the arrow went all the way up, and then goes exactly back down to the same spot, the same elevation. Okay, so in this case, we can assume that the time it takes to go up is equal to the time it takes to go down. Okay, and this in all is just simply the time or the hang time, which is what we got, over 2. So if I get my calculator real quick, again, it's off camera, sorry, because it's Minecraft, I cannot really put the calculator up. So hang time over 2, that's 5.52 divided by 2, that gives me 2.76. Okay, so the time it takes to go up is equal to the time it takes to go down, which is equal to 2.76 seconds. Okay, now we can use this value. So let's say we want to determine what the delta y is. Now Minecraft is very convenient because one block is equal to 1 meter. Okay, so we know that the time it takes to go up is 2.76. What else do we know? Well, we know that gravity exists, negative 9.8 meter per second squared. Okay, what else do we know? Well, when we're analyzing the going up motion, we know that Vf is equal to 0. I mean, sorry, not Vf, but Vi is equal to something, and then Vf is equal to 0. And then when we're analyzing the going down motion, Vi is equal to 0, and Vf is equal to something. Okay, so let's try to do it using the going down motion because I think we can get an equation out of it. So if we analyze the going down, we know that the Vi is equal to 0 because it just falls the same distance as it flies going up. Okay, so we are given T, we are given A, we are given Vi, and we're looking for delta Y. This will then lead us to use the equation delta Y is equal to VIT plus 1/2 AT squared. Okay, so we're analyzing the going down motion because think about it. If we were to use Vf, or if we were to use the going up motion, then there's no equation that actually gets exactly as good as this because Vf is not Vi. So if we analyze the going down, at least we have Vi. So again, delta y is equal to VIT plus 1/2 AT squared. We know that Vi is equal to 0. Let me just change the ink a little bit. We know that this equals 0, and we're just simply going to be left with 1/2 AT squared is equal to delta y. Now let's plug in the values. We know that A is negative 9.8. We know that the time going down is 2.76 seconds, and we want to square that. Okay, so again, I'll get my calculator real quick. So 1/2 times negative 9.8 times 2.76 squared gives me a value of 37.3 in the negative direction. So this is the 37.3 meters in the negative. It's negative because we analyzed the going down portion. But if we were to then convert this, delta y, or the height of the flight of the arrow, is simply 37.3 meters. Okay, so that's how to compute for delta y using the hang time principle. In hang time, again, remember that going up is equal to going down, and therefore we can make these assumptions, calculate delta y. Another thing we can calculate using this, let me just refresh my I'm just going to refresh my paint. I'll not save that. I'm gonna make it green. Green is easy on the eye and it looks like a blackboard, so I'm gonna use that. Okay, so let me get my brush out. So let me again remember that the hang time that we got is around 5.52 seconds, which means that T up is equal to T down is equal to 2.76 seconds, and we did calculate that the delta y is 3.7, or not 3.73, sorry, but 37.3 meters. Okay, and let's say we now want to get the VI, or the initial velocity by which we launch the arrow. Okay, we know that gravity is equal to negative 9.8 meter per second, and if we're going to get the VI, or the initial velocity at which we launch the arrow, well, this time we have to analyze the going up motion. Okay, this is the VI. VF, you know to be 0, because at the very top it's 0. So now we're going to analyze the other side of the motion. Okay, so we're actually going to use the same equation, delta y is equal to VIT plus 1/2 AT squared. Okay, so this time we're going to look for VI. Let's rearrange this a little bit. Delta y minus 1/2 AT squared all over T gives me VI. And if we plug in the values, let's do it. 37.3 meters, because it's going up, minus 1/2 times negative 9.8 times the time, which is around 2.76 seconds, because again, we're going up, squared, all over the time again, so that's 2.76. Okay, let's get my calculator out. So that's 37.3 minus 1/2 times negative 9.8 times 2.76 squared all over 2.76 gives me a value of 27.0 meters per second. Okay, so the VI of this one would then be 27.0 meter per second. It's pretty high. Arrows shoot through the bow of Minecraft pretty high. Anyway, so those are just some sample calculations using hang time. We did compute for delta y, which is the maximum height. We could also compute for VI. And we could also compute for time if we're not given the time. If we're given the delta y, the maximum the height, then we could use that to compute for hang time. One other thing we have to take note of would be VF, or the final velocity at which it lands. Because it lands in the same place, and because the time it takes to go up is equal to the time it takes to go down, we can actually assume that VF is actually equal to negative VI. It's just the absolute negative of which you launched your arrow. So if we were to get the VF of this one, it will simply be negative 27.0 meter per second. Okay, so I hope this makes sense to you. I think we're going to do a laboratory activity eventually, wherein we're going to compute for the hang time of your jump. Okay, so I hope you look at this video to prepare for that laboratory activity. Thank you for watching, and I'll see you this week when we do hang time. Take care.